Hello, this is Jason Glazer, the Vice Chair of SPC 229 and the Chair of the Schema Working Group. Today we are going to try something new. At the SPC 229 meetings, a higher priority right now is to discuss major issues. So instead of presenting and voting on pieces of the schema during those meetings, we're providing this video to explain the details of a portion of the schema, followed by a discussion by email and then a letter ballot. We encourage discussion by email, and hopefully any issues that are brought up can be included in a modified version of the schema by the time we are ready to have the letter ballot. For now, we are going to leave 1 week discussion after the video is sent to the SPC before we do the letter ballot. If during the discussion more substantive changes are proposed, I will refer the changes back to the schema working group for debate and will postpone the ballot on those data groups. Another new thing is how we're going to vote. We are going to try the ASHRAE letter ballot system. You will get an email about the ballot when it opens with the subject line starting New SPC 229 Ballot. It is very easy to use and really doesn't require instructions, but some instructions are available to you if you want and were included in the email as a link to the video. While this approach does mean watching videos and some additional email, I hope the SPC members can watch and respond when it's convenient to them, so this process is easier for everyone and gets all the data groups approved. If the approach works, we will continue to release these videos followed by an email discussion and letter ballot every couple of weeks. The link to the web page that we've been using for the development of the schema is shown on the email, and I'll show it to you now. One of the things that it includes is the status of all the data groups. And you can see by clicking on data group status markdown that a lot of things have been approved by the schema working group and also by the SPC. But there are still a lot of things that have not been approved by the SPC yet. So we're going to be going through those one step at a time. Today we're covering 3 related data groups. Chiller, find it. Yeah, ChillerCapacityValidationPoint, and ChillerPowerValidationPoint. All right, so let me go through the description of the data groups just like we normally do. So first of all, let me give you kind of a background on where things land here in the overall connection diagram. This is how all the different data groups are connected up. And if you scroll down to this area, the bottom right, you'll see that fluid loops are kind of the central point for a lot of things that are attached to a fluid loop. Pumps, cooling systems, heating systems, chillers, boilers, heat rejection, all that kind of thing, all attached to fluid loops. Chillers reference the fluid loop by reference rather than being children of the fluid loop. We've previously looked at boilers. Where is that? Boilers over here. We've previously looked and approved boilers, and in a lot of respects, chillers are very similar to that, but have a little bit more complicated things that go on. So the first thing I want to show you is that even though chillers are reference fluid loops, they're actually children of the rule set model instance. So if you go to that data group, you'll see down here that a list of chillers is one of the things that's involved in that. So that's where they live, but they are mostly connected by references, and I'll go through that in a little bit. So as almost all other data groups, the chiller has an ID, reporting name, and has a place to put notes. And then it refers to cooling loop and condenser loop. So these are references to the loop, as well as a little bit further down for heat recovery, there's a reference to a heat recovery loop. So it references 3 different loops altogether. Obviously, for an air-cooled chiller, you wouldn't be referencing the condenser loop at all, but for most water-cooled chillers, you would. So following those loop references are a list of an enumeration for the compressor type, and then the energy source type, and then several capacities, the design capacity and rated capacity. Those are often different for chillers, especially centrifugal chillers. And then the minimum load ratio. So this is how far down the chiller what fraction of the capacity the chiller can go down to. And then there is some design flow rates for the evaporator and the condenser side. And then full load efficiency. So this would be the efficiency described as a coefficient of performance for the chiller, the overall chiller. And then a part load efficiency. And that can be described in several different ways. So there's actually an enumeration about what metric is being used for the part load efficiency. And then there's a reference to capacity validation points and power validation points. Those are similar to the validation points that we have proved previously on boilers, and I'll go over those in a few minutes. And then finally, there's some 2 booleans having to do whether the pumps for the chilled water and condenser water side are interlocked with the operation of the chiller. So basically, if the chiller is operating, whether the water pump is interlocked with that or not, and the condenser water pump. And then finally, the chiller heat recovery loop has a reference to the fluid loop, as well as what fraction of the heat recovery is recovered by the chiller. So let me go over the enumerations now. We had several. They're back up here near the top. All right, so the compressor options for chillers are kind of what you'd expect. Screw, centrifugal, reciprocating, etc. And it also includes absorption. So these are typical types of chillers that you would see. And then the efficiency metrics. For most chillers, the IPLV, or integrated part load value, is the metric for part load efficiency, but then there's also a non-standard part load value that's could be the way it's described, and there might be some other efficiency metric. In that case, you just select other. And then the energy source options for chiller, that was another enumeration, are what you typically expect: electricity, natural gas, etc. So that is everything about the chiller itself. And then the next thing is to describe these validation points. So the concept of the validation points is that if a rule set describes the detailed performance of how a chiller should have part load curves or something like that, these validation points would be provided in order to verify that the model correctly is using those part load curves or tables lookups or whatever else they're using. It's not the same as a part load curve. Basically, we're just trying to make sure that different points on the curve line up. So we expect that the simulation software or whatever's generating this would provide that level of detail about the chillers. So for the capacity validation curve, there's the chilled water supply temperature and condenser temperature, as well as the capacity itself, or result. Now for air-cooled chillers, the condenser temperature would be the outside dry bulb temperature. Likewise, for the power validation points, they have similar inputs, but they also add the word load. So at different load levels, there'd be different results. So basically, between these two lists of validation points, you'd be able to completely describe basically points in both the capacity and efficiency curves for chillers. One thing you might note is that neither of these two validation point data groups have name or ID. They're always children to the chiller, and it seemed unnecessary given that they're going to be a repetitive point. There might be, let's say, 10 or 15 of these. So, all right, and I think that's all that I have to say about these three data groups: chiller, chiller capacity validation point, and chiller power validation point. I would like you to take a look at them, and if you have any questions or comments about the different fields, just respond to the email that we sent out initially. Thanks for watching the video. Hopefully in about a week we'll be sending out a letter ballot, and you'll be able to vote on this. So thank you very much, and stay tuned.